Aufzeichnen? Okay, alles klar. Dann herzlich willkommen zum Lunchtime-Seminar. Der Michael Brottrager hat sich ja dankenswerterweise bereit erklärt, das heute zu machen. Das ist eine Arbeit, die mit dem Young Economist Award von der NÖK ausgezeichnet wurde, gemeinsam mit dem Lorenz Fischer. Ich möchte jetzt noch mal kurz darauf hinweisen, wie wir das jetzt abhandeln. Ich habe euch alle stumm geschaltet. Wenn ihr eine Frage habt, ihr könnt unten gibt es ein Fenster, da steht Teilnehmer. Wenn ihr darauf geht, dann gibt es unten eine Leiste und da steht Hand heben. Und wenn ihr die Hand hebt, dann wissen wir, dass ihr eine Frage habt. Wir werden dann den Michael unterbrechen und euch dran nehmen. Okay, ich hoffe, dass das funktioniert. Ihr könnt sie alle mal kurz probieren. Ja, Michael, Rudi funktioniert, Daniel funktioniert, Jochen funktioniert. Okay. Falls sie bei irgendwem nicht funktioniert, vielleicht kann er sich kurz melden. Ihr könnt also die Mikrofone sind stumm geschaltet, aber wenn ihr die Leertaste drückt, dann könnt ihr temporär das Mikrofon einschalten. So könnt ihr zu allen sprechen. Ja, ansonsten würde ich euch bitten, dass ihr die Mikrofone ausschaltet.
Wichtig draufbleiben auf der Leertaste.
Alex, kannst du nur mich bitte wieder einschalten, weil ich kann es nicht mehr selber, weil du mich stumm geschalten hast.
Okay, das macht Sinn, dass wir den Michael nicht stumm schalten. So, Michael, das müsste jetzt funktionieren.
Perfekt.
Alles klar, dann, ich glaube, wir machen 45 plus 15 Minuten. Wie gesagt, bitte Hand heben, wenn es eine Frage gibt, Michael.
Okay, great. So thanks for your coming to the first webcast seminar. Today, as Alex mentioned before, I'll present the joint work with Lorenz on costs of mobility and regional unemployment in Austria. To our motivation. In the year of 2002, as you can see here, the mean unemployment rate was about 5.8% across all labor market districts in Austria, with a standard deviation of 1.5%. By 2016, the mean unemployment rate rose up to 7%. And in line with that, the Austrians in the labor market districts, across all labor market districts, got more mobile, indicated by the increase in the average commuting rate and the average internal migration rate. And this is somewhat at odds with the notion that higher levels of mobility should lead to smoother functioning labor markets. So this paper attempts to clear the view and to assess the general impact of regional mobility, theoretically and empirically. And to do so, we apply a multi-regional search model in which simultaneous movements arise from unemployed workers and searching across all regions. In a simple example, we show that shocks increased in mobility. Shocks that increased mobility rates increased disparities in unemployment. So for the conclusion of the theoretical part, we find that the ultimate effect of labor mobility on regional employment differentials depends on the state of the system. So the state at which each labor market is currently at. This can be used to explain such contradicting or seemingly contradicting results as presented in the first slide. Empirically, we study we recognize the deep simultaneity between labor mobility and unemployment. And in order to get a reliable estimate of the impact of labor mobility on unemployment, we suggest using estimated mobility costs. And we do that with Austrian data. The intuition on that approach rests on the argument that estimated mobility costs are not based on labor market characteristics, such as labor demand and labor supply, but merely on geographic distances between labor market districts. And that allows us then to infer on the impact of changes in the attitude of mobility, for example, and regarding those costs. as mentioned, the reliability of this estimate stems from the fact that the gravity estimate of total mobility costs, as implied by distance, is unrelated to the status of each labor market district. And this is because we control for each of the states or each sender and receiving labor market district states.
Michael, es gibt eine Frage vom Jochen.
Ja, bitte.
Okay, mit Leertaste. Do we stick to the 10-minute rule or whatever we had in the official seminars?
Go ahead.
Otherwise, okay. So I don't quite understand what is the shock here in your theoretical model. So could you please clarify what is changing in the background and then what you're analyzing?
The shock in the theoretical model is, or the exhaustion is the mobility costs. So it gets cheaper to get from A to B and vice versa. Yeah, so furthermore, we are, by estimating those mobility costs, so costs of commuting from A to B and costs to migrate from A to B, we find that migration costs have stagnated and commuting costs have decreased markedly. Finally, we were able to associate those decreased commuting costs to relatively lower unemployment rates in labor market districts. So it seems that those decrease in commuting costs has dampened the increase in unemployment. However, we do not find any such thing for migration costs. Okay, so to our theoretical part here. Or first the literature. So as mentioned before, the literature isn't, yeah, there are diverging results in the literature as, for example, increasing results or increasing disparities as related to increase or decrease in regional mobility, decreasing disparities, and neither. And how are these conclusions reached? So most of the studies presented before interpret just the sign of net migration and use that to argue converging powers of internal migration, such as positive coefficients would imply convergence and negative coefficients would imply divergence. Furthermore, all those contributions don't regard commuting, and we especially do that. Okay, so the model presented in this section is an extended version of a standard search model. But the first difference is that while in a standard search literature, they're dealing with individuals, we try to extend those models to the region level, so the aggregate level. And furthermore, we extend the two-region model to a multi-regional framework. Furthermore, space enters the framework via migration and commuting costs that are associated with distance. So the higher the distance, the higher the costs. And using those commuting costs, we are left with this scheme here. So unemployed workers, so with some probability pi, people get unemployed, and then with some probability pi, so this is labor market district specific probabilities, they get a wage offer, which they can accept or decline or reject. And if it's a home offer, I can accept at no cost because I don't have to move, I don't have to commute. And if it's a wage offer, I can move to the new labor market district to work there at cost M. And those migration costs are assumed to be paid up front. So you have to buy a new house, for example. Or you could decide to commute to the labor market district in question. And then there are associated commuting costs tau, which we interpret as some kind of iceberg cost. So if you accept a wage offer in labor market district K, then the reservation wage just includes those commuting costs. Otherwise, you wouldn't accept. Okay, so yeah, as mentioned before, moving to another region is only possible when a proposed match is accepted and entails those costs, migration costs and the commuting costs. And both migration and commuting costs are increasing functions of distance, so we don't allow for any non-monotonnicities there. So using this framework, we are left with 3 reservation wages. So the reservation wage in our home offer case is just our indirect utility function with some depreciation rate here. Then our reservation wage in the migration case, so a worker would accept if she decides to migrate, is just the reservation wage plus the migration costs plus the differential between the home offer and the away offer. And finally, the commuting costs interpreted as iceberg costs. And the main difference is that migration costs are paid up front and commuting costs are just say fuel and so on.
Michael,
using, yeah.
Michael,
Please,
sorry
yeah.
to interrupt you. Why do you use iceberg transportation costs? Does it have technical reasons, or is it some theoretical arguments that commuting costs can be approximated very well by iceberg transportation costs?
So we, for the iceberg costs, we just stuck to literature, so it's used more often, and in that case, it's easier to handle here. And we assume that it better reflects the commuting behavior. So if I'm commuting from A to B, I have a static cost, a steady stream of costs, iceberg costs. And if I'm migrating to B, then I have to say rent a new flat, move there, have moving costs that have to be paid upfront, for example. So no specific reason there. So using the offer probabilities or match probabilities in conjunction with our wage draws, we are able to compute 3 hazard rates. So the hazards that I leave unemployment, so in the home, given a home offer, given a way offer, and in conjunction with migrating, and the hazard rate in conjunction with commuting and migrating. So if we then turn to the changes in unemployment rate, we are left with this pedagogical equation here. So the change in unemployment rates are affected by local unemployment growth. Local employment growth, the out-commuting growth, the out-migration growth, and the in-migration growth. And obviously, this equation is endogenous because, by assumption, only the unemployed surge. And to get an estimable claim, we use our hazard rates here to rewrite the equation here. So we decompose our commuting cost or a change in the commutes as the probability of out-commuters that got unemployed. So it's the new unemployed that have been commuting before, the change in the local employment growth, and then the migration, the out-commuting. So these are the new commutes that accept a wage offer from a different host labor market district, and then the hazard rates and for the in-migrants. So this is the additional labor force that comes into our home district.
Michael, es gab eine Frage von René.
Ja, bitte. René, ich glaube, du musst dich...
René, wir hören dich nicht.
Besser? 1, 2?
Ja, jetzt geht's.
Okay. Diese Änderung der Arbeitslosenrate, da scheint es mir, dass die Arbeitslosenrate nur auf die lokalen Änderungen reagiert und nicht auf die Änderungen in den potenziellen Destinationsorten, Gebieten.
Entschuldigung, bitte nochmal, ich hab's nicht.
Arbeitslosigkeit reagiert hier nur auf das Wirtschaftswachstum im eigenen Bezirk und nicht auf das Wachstum in den anderen Bezirken. Ist das richtig?
Genau, also wir sind dann nicht in einem General Equilibrium Framework, sondern wir haben es nur im Local Labor Market District. Ist das? Beantwortet das die Frage, oder?
Nein, ich kann mir vorstellen, wenn irgendwo in der Nachbarregion ein Wirtschaftswachstum ist, dass das irgendwie unter Umständen auch Arbeitslose aus diesem Bezirk attrahiert.
Ja, dann soll, wenn im Nachbezirk die Employment Growth, klar, ja sicher, genau. Also wir haben das dann in unserer Empirical Strategy dann drinnen, genau. Also das, wie gesagt, das betrachtet jetzt nur in diesem, also im Home Labor Market District I. Okay, so having our
Lorenz? Entschuldigung, Michael, das war eine Frage von Lorenz.
ja.
Nein, aber keine Frage, aber ich glaube, das würde man einfach in die Hazard Rates sehen. Wenn man auswärts commutet oder auswärts hinzieht, dass die Hazards da größer werden, wenn wir da mehr Arbeitsnachfrage haben.
Ja, genau. Okay, so having our theoretical framework laid out, we are left with 4 hypotheses. So we know that commuting and migration costs drive reservation wages, and the matching probabilities decrease in higher associated costs, which in turn lower the hazard rates of employment. So we have our 4 hypotheses that are the cost of outmigration have a positive impact. So if my unemployed leave my home district, then overall unemployment rates decrease. Abstracting from job competition, we are left with the hypothesis that cost of immigration have a positive impact because then the number of employed rise. However, if we allow for job competition, then the effect of immigration might turn negative. So if, for example, the same holds true for outcommuting. So outcommuting per se has a positive impact because the unemployed in the home labor market district leave for another labor market district in the vicinity. And the incommuting are not expected to have any effect. Although if we allow for job competition again, then we might have a negative impact. And as mentioned before, we have no general equilibrium setting, so the labor demand and production is not included. And so we have to account for those potential competitive natures of mobile searches. Okay, so now we turn to the empirical part. And for that, we use data from the Public Employment Service in Austria, which provides detailed data on employment, unemployment, and vacancies for all of its 96 offices, starting in the early 90s. For our purpose, we aggregated Vienna, so we are left with 83 labor market districts. Furthermore, we use Statistics Austria's data for origin, destination flows, and relocations, and commuting, starting from 2004. Commuting starts in 2009 at the municipal level. And this data is used in conjunction with payslip data to estimate the mobility costs. As the Statistics Austria time series
quick clarification. How is the Statistics Austria data collected?
At the municipal level.
No, but who is collecting that data? Since there is no real census anymore, I'm wondering how Statistics Austria determines the commuting.
They determine the commuting by if the worker is in a different municipal than the employer, then that's commuting.
I understand, but where is Statistic Austria obtaining this information?
I'll have to look at that again. So maybe Lorenz, do you have some information on that? But I have to look it up, actually.
My guess is that they use a procedure which you could do yourself, which is using the ASSD data and other data sources. I was just wondering whether Statistic Austria has any way to come up with to solve the establishment versus headquarter problem.
Okay. Yeah.
From 1971 until 2001.
We'll have to look it up.
From 1971 to 2001, Austria has very good commuting data, which I think are almost unique on a country-wide comparison. But beyond 2001, I don't know how it works, and I'm wondering whether you want to use earlier data to exploit that uniqueness.
Okay, thanks.
Before, from 1971 to 2001, you also know the mode of transportation.
Okay, great. Okay, yeah. So anyways, we augment the Statistics Austria data by using the payslip data with access to from the Austrian Ministry of Finance, and using the ISSD data in the sense that we just look at where is the worker from and where is the employer from. So that's then computing. And relocations we get from payslip data. So we have the postleitzahl for each year, so for each payslip, and then we look at incidences when those locations change. Having those locations of employees and employers, we just use travel times and distances by car using the open source routing machine. So we just compute normal travel times between each municipality center. Sorry. Okay. So our strategy is in that sense that in the first step, we approximate the cost of geography by estimating a gravity model of commuting and migration using a pseudo-Poisson maximum likelihood estimation. Then in the second step, we use those estimated costs of geography, and cost is kind of perceived costs, to estimate the potential effects of those costs of mobility. Why are we doing that? Because typically it's hard to find valid instruments that are usable for investigating migration flows. And the more important point is that we are not interested in actual migrations, but rather in the outcomes of mobility choices, such as the associated cost of mobility. So how does the cost of mobility affect the unemployment, or how does the tendency to migrate has effects on unemployment? So therefore, we follow Bertoli-Morgara and Artug to estimate this PPML estimate structure here, where we control for sender time and receiver time fixed effects. And given that all labor demand effects, or labor demand shocks and labor supply shocks in the sender and receiver labor market districts are or pertain over all districts, then our vector delta t, so our coefficients of the distance matrices, should reflect actual costs of migrations. Besides distance, our d prime dij includes indicator variables such as interaction terms, such as whether the sender or destination is in a western state of Austria, or it's in a southern state of Austria, or if Vienna is either destination or the origin, and where the travel time is less than 50 minutes. And after that, we use the estimated migration costs in the second step. However, before that, it's worth noting that we estimate those costs of migration at a municipal level, and therefore we have to find a proper way of aggregating. And in our vanilla form, or in our baseline specification, we just use the plain travel times. And so between the municipal center and the destination center, and then we aggregate over all those connections within a labor market district. However, while the measure of distance is by construction a proper way of reflecting space or geography, it does not account for the importance of each connection. So a connection from, say, Hintertupfing to Vienna might be more interesting than from Hintertupfing to some village in the Waldviertel. So we propose a second measure of distance, or accessibility in that sense. And for that, we use a two-step floating catchment area approach, as for example, proposed by Bennersdorf and Bennersdorfer. And in the first step, we calculate for each municipality in Austria a measure of relative importance to its neighbors. So it's in terms of population. So it's the population of this municipality divided by distance-weighted population of all its neighbors. And in our main specification, our ETVA is -1. But in our robustness checks, we show that the choice of our distance decay function is has not that many effects on our results. However, in our next step, we relate our RK, so our relative measure of importance of local centrality, to the neighbors. So for each community or municipality K, we compute the relative importance of its neighbors. So it's just the distance-weighted sum of our local centrality. So for example, it is we would expect that Vienna has quite a small accessibility, because Vienna itself is very central, so spatially central, and the neighbors of Vienna are not central that much, so AK would be low in that case. Furthermore, AKJ would be low for say municipalities in the Waldviertel, where the communities themselves are quite uncentral, and the vicinity or the neighbors are not central as well. Okay, so, and then in the next step, the final step, we just aggregate those accessibility measures at the labor market district level. And as it's an accessibility measure, we just take the inverse to have a distance measure. Okay, so to our actual estimated mobility costs, as you can see here, the average mobility costs or commuting costs seem to have decreased over time, whereas the migration costs stagnated, or they did decrease to a lesser extent, or to far less extent. So in the second step then, we want to estimate in line with our theoretical model this equation here. So we want to relate our commuting costs here and our migration costs to our local labor market unemployment rate. And here we are applied with some potential issues, namely that given the relative short time horizon, our results are prone to the nickel bias. And furthermore, unemployment rates are quite autocorrelated over time. So normal Arrow-Lano bond type estimations are prone to over-identification and or random initial conditions as well as weak instruments. So because of that, we employ an bias-corrected estimator as proposed by Barney and Kvyat, which uses the initial estimates obtained in a GMM framework. However, as mentioned before, in a GMM framework, we have those issues. So to just keep an eye on potential issues, we computed the upper and lower bounds of a consistent estimate, and any consistent estimate should lie between the fixed effects estimate and plain OLS estimate. So if it's between those bounds, we should be fine. Okay, so then to the results. So in the first column, you see our baseline results where we employ a plain distance measure. And we find that migration costs seem to be negatively associated with unemployment rates, while commuting costs seem to have a positive effect on the local unemployment rates. However, we were concerned that there is still a lot of spatial interactions spatial interactions present in our model, in the model framework. So we proposed to include lagged vacancies. So the spatially lagged vacancies in our model, as well as employ spatial filtering process, as we are not interested in the spatial process per se, but just try to filter it out. Doing so hardly affects our baseline estimates, so the estimates stay fairly robust. However, if you turn from our plain distance measure to our proposed accessibility measure, we get quite a different result, especially in terms of migration costs. So the negative coefficient of migration costs decreases in size and is rather insignificant, while the computing cost estimate seems rather robust. So if we return to our model predictions, theoretical model predictions, we would, seeing those estimates here, we would state that in our system, there might be some competition effects ongoing, while it's not so much the case for commuting. Okay, so for robustness checks, we tried to do a rural urban split. So we differentiate between labor market districts that included, say, state capital, and commuters that labor market districts that do not so. And what we can see here is that the migration cost effect seems mostly driven by those state capitals, while it seems not to be the case for the commuting costs. Here in the second row, we dropped Vienna and all its neighboring districts. And what you can see, and kept the rural urban split dense for the rest of the labor market districts. And what we can see here is that the migration cost parameter seems to be driven by Vienna here. And finally, using our accessibility measure, we are able to differentiate between in-commuting and out-commuting, we could not do that with a plain distance measure because a plain distance measure would be symmetric. So the distance from, say, Leoben to Vienna is the same as from Vienna to Leoben. However, the accessibility measure or the relative importance measure is different for both directions. So we are able to differentiate between inflows and outflows. And doing this, we are able to find that the positive effect of commuting costs seems to come mostly from outcommuting as opposed to incommuting, which has no effect or seems to have no effect. And the last column here, 10, again excludes Vienna and its surrounding labor market districts. Yeah, Jochen?
Sorry, Michael, I feel kind of lost. So the positive coefficients here, they mean that higher commuting costs lead to higher unemployment in these regions, right?
Yeah.
But you saw a trend of unemployment across regions or across municipalities in the very first slide you showed us.
Yeah.
And at the same time, you saw a downward trend in commuting costs. So it seems that overall there must be something in the background, some aggregate effect that is working the other way. So that, first of all, leads to higher unemployment, and then you have some buffering effect of the decrease in commuting costs. Or how does it all square?
Yeah, that's our argument, that the increase in unemployment got dampened by a decrease in the commuting costs.
I see. Okay, so you take something as given in the background, and that you don't even try to model, but then you say that, okay, on top of that, what is happening? Okay.
Yeah, that's our argument, yeah. Okay, so having done that, we were able to confirm our hypothesis regarding the outcommuting, that we do find positive effects associated with the with outcommuting costs as opposed to incommuting costs, and there might be some computational effects ongoing in migration. Another explanation would be that, as you said before, that the migration costs seem very stable. So we have not that much of a variation ongoing in those costs. That might explain some of those results as well. So to our conclusions, we propose a theoretical model incorporating the migration and computing, and we are able to say that mere sign interpretations are not able or should not be used to explain convergent and divergent powers. In general, we find a decline in average commuting costs, not so much in migration costs, regardless of how we aggregate from municipalities and labor market districts and how we compute our distance measure. So if it's the plain distance measure or the accessibility distance measure. Using this estimated mobility costs over time, we are able to find that commuting costs seem to have dampened the increase in unemployment rates, while migration costs do not seem to have an impact, even if we exclude Vienna and all its surrounding labor market districts. However, the results, to obtain those results, it is important to go away from plain distance measures and use the accessibility measure proposed by us. Finally, it doesn't matter which kind of filtering we are using, if it's SAR filtering or STM filtering. So yeah, thank you for your attention, and I'm open for any questions then.
Okay, thank you so much, Michael. We have plenty of time for questions. Please just raise your hand. Okay, there is one from Matthias.
Yeah.
Okay, do you hear me?
Yeah.
Okay, so I was wondering, because you basically assume that migration and commuting costs generally have a positive effect on the likelihood of doing that. But basically, for me, migration, but there's also basically some exchange. For example, if there are forces that reduce the costs of migration and commuting, at some point, you might basically then switch from migration to commuting. And this then might lead to a situation that lower migration costs actually lead to less migration. You understand what I mean? Can you capture something like this?
Sorry, the middle part, I didn't quite get the middle part. So
okay, so basically, let's assume, okay, migration and commuting costs go down, and basically the forces reducing both of them are basically the same, right? So both go down. But so for people, this is a discrete choice. So at some point, you might switch from if you're thinking about accepting a job somewhere, you might not move anymore, but instead you might commute there.
Yeah.
If the cost goes. And therefore, lower migration costs could actually lead to less migration because they also reduce the commuting costs, and therefore you switch from migration to commuting.
Okay, yeah. So as both commuting costs and migration costs are functions of distance, there is some zone in our distance space where we have a pure commuting zone. And if the costs of distance decrease, then people might change from migrating to commuting. So, but they accept away offers. So if it's if distance per se is very costly, then they abstain from commuting and from migrating. And if the cost of distance for exogenously rises, then those that so if the gradient for migration costs increases, then there might be some intersection between the costs of the cost function of commuting and cost function of migrating. And then you're right, then people would choose commuting as opposed to migrating. But I don't see why that should affect our results then, because distance, the costs got lower in in both cases then.
Yeah, I don't know, maybe it's just concerning the interpretation of your results that might, because this might, I don't fully get, but maybe this might sometimes explain this negative sign of migration on unemployment.
Okay.
You know?
Okay. René als erster und dann der Jochen, bitte. René? Vielleicht kann der Jochen vorher seine Frage stellen.
Ich glaube, René muss auch die Leertaste drücken.
Das macht er ja eh.
Okay, jetzt geht's. Willst du erst, René?
Nein, sprich nur.
Okay, zwei Fragen. Das eine ist nochmal clarifying. So, do I get it right that the overall trend in unemployment, that just doesn't matter in your estimations because everything is across municipalities. So that washes out completely in the estimation. The second one is kind of related to Matthias' question. So you're comparing a fixed cost to a time-specific or a time variable cost. And what that means is that also discount factors, the duration or expected duration for which you will be commuting, that will differ. So in your model, can you account for that? So, and what is the expected duration of the commuting and so on? Because when comparing costs, what matters is how long do you expect to either be commuting or either be migrating?
If you, for expected cost, I think we could introduce it fairly easily, I think. Right now we know that, so we now assume that you know the costs and you're employed at your employer in labor market district B, for example, and with some probability pi, you got laid off or you just get unemployed. So that's the duration of your employment status. But you know the costs associated with that commute.
So you're basically just comparing two present values right now.
Yeah, we do that. So by introducing an expected value, we just would have to introduce that in our model form. So just at the expected value, so with a probability of, say, pi, I'm employed there for n times, and the commuting costs over time are expected to decrease then. So, but we don't model that right now.
Can't you infer something like monetary values of, the daily commute or the monthly commute and compare that with the data? So whether the model implies something that actually makes sense when you compare it with the data.
So you propose using I didn't get with the daily compute and the monthly compute. So
I think that right now what you have is just two numbers, but you should be able to relate that to the expected time that you will be commuting to this other municipality, and that expected time together with your overall number or cost gives you then a monthly number of cost of commuting, and that could be related much more sensibly to your estimate of the commuting costs, how that decrease over time, whether that is realistic or whether that is just capturing a lot of other stuff that is going on.
Okay, yeah. So for that to work, I think we would need the actual incidence of commutes on a weekly basis. So how often do I get from my hometown to my employer? And with the payslip data, I think we could do it for a subset, for the subset of fully employed individuals that only have one single job and just use it for that. For commutes for, say, part-time employees or employees that just commute 3 times a week or whatever, I think we don't have any data at hand. So, but we could do it for just full-time employees then, where we expect them to commute on a daily basis, for example. And yeah, our migration cost and commuting cost estimate admittedly is a black box. So it's perceived costs, it's everything that makes you more likely to accept the cost, actually, or the constant distance in the most simple form. So yeah.
Okay, thanks.
Okay, are there any other questions?
René?
Yeah, René, he doesn't have a question anymore, it seems.
Then I may ask one. In your distance measure, I mean, it's travel times, but nevertheless, it's only a cross section. You didn't have a subscript T at the distance measures.
Yeah.
But do you observe changes in transportation infrastructure, like the Westbahn is much faster than it used to be 15 years ago?
In our current specification, we use constant travel times. So the main reason is that the travel times did not decrease that much. So okay, the Westbahn has a high interval, for example, and some motorways, I think the Alba tunnel got open and so on. So there is some incidences where you could argue that those incidences led to decreased costs of distance. However, we considered them too low to actually use that. So for our current specification, we just use a static measure. So the road distance or the travel time distance is the same for each year then. And for the accessibility measure, then the population comes into play. So that one actually varies, but not that much. So in the end, it's fairly stable as well.
Tom?
I don't get how in and out commuting costs can be really different.
Tom, wir hören dich nur sehr schlecht. Ja, jetzt ein bisschen besser.
Ich verstehe nicht ganz, warum die Out- und In-Commuting Costs unterschiedlich sein können zwischen 2 Gemeinden, weil entweder da gibt es Straßen oder nicht.
Michael, ich glaube, ich habe es auch nicht hundertprozentig verstanden, aber ich glaube, die Gist der Frage war, warum die In- und Out-Commuting Costs unterschiedlich sein können.
Regarding out-commuting commuting costs and migration costs, we assume that if you decide to migrate, you have to actually say buy a house or buy a flat or whatever, rent a flat. So the consideration that or the thinking process that is associated with my decision to migrate commute might be different. So in commuting, in our setting at least, we use just road distances and travel times by car. You just need your car, so there might be differences. So we could just as well use plane distances and aggregate, but I don't think that it would change that much. So if we just use a composite of migration and commuting costs, or just estimate it as one kind of distance costs. But we thought that it is worth it to differentiate between, or to allow for different commuting costs and migration costs.
But why can the costs for in-commuting and out-commuting be different?
In our distance measure, so if we use the plane distance, the distance measure is symmetric. So in that case, they aren't different. In our accessibility measure, then it's the relative importance. So I'm more willing, for example, more willing to accept higher costs to commute to Vienna as opposed to commute from Vienna, because Vienna is more central. So it's relatively more important. And then those in and out streams might have different costs associated with them. In our plane measure, so in the plane distance measure, it is symmetric. So they have the same cost. And that's the reason we can't estimate in and out commuting costs in that framework, because it's symmetric. So we could either estimate just in commuting or out commuting, but not both. But the strength of our accessibility measure is that it is asymmetric, and then we could allow for different costs.
Any other questions?
I have one question.
Yeah.
For your accessibility measure, now you're using population,
Mm-hmm.
but wouldn't it be more precise to use number of jobs or employer in a municipality?
Yeah, we thought about that, but we feared that that would be, to some extent, endogenous or related to the labor market conditions then. So we thought we just used the population, because it's not a direct consequence of migration then, or labor market conditions, which we try to control for in our approach. So we could use number of employers in each district, for example, but then if for example, the unemployment decreases because more employers are there, then I don't think we could interpret it as direct cost of migration then. So we weren't sure if that would be a right way to go.
Yeah, there's still time.
Mm-hmm.
Okay. It seems like there are no more questions. All right. First of all, I will stop the recording. Wait a